We are back with DTNsights. Really fired up for this episode. It might be springtime where you are, but we're going to talk about tropical season and get into hurricane season. And I couldn't think of anyone more qualified to talk about that and more excited to talk about that than my man, Nathan Hamblin. Nate, how are you doing today?
Oh, doing fantastic, Renny. How are you today?
Doing great. Nate serves as a weather risk communicator here at DTN, focused on long-range forecasting, which is a really kind of unique skill set inside the world of weather. When we talk about forecasting, most people are thinking about what's today going to be like or the next few days. But Nate, you focus on really an extended outlook. Some would say like really even out to a year in advance, you start kind of thinking sort of where is the pattern heading. So I'm curious to learn a little bit about you and your background. What led you into kind of this long range specialty? How'd you get into weather to begin with?
Well, started a long time ago. I was a young man up there on the Tug Hill Plateau in upstate New York, where we used to get a lot of lake effect snow. And that's what kind of drove my interest into getting into weather. So set on a mission to learn about all that and maybe even make a living out of it. And we've come a long way since then. Went to college, SUNY Oswego, upstate New York, right in the heart of lake effect snow country. So couldn't pick a better spot to learn it. And then I got my first job in meteorology, and it went in a slightly different direction than maybe I thought. I started getting into the energy sector a little bit, and I got to learn a little bit about forecasting day to day. And there's a demand for more medium and long range forecasting that didn't really see a lot of people doing at the time. So I took it upon myself to learn about all the intricacies of that. And really what long range forecasting is kind of a weird way of saying paying attention. You have to look back into the past and see what kind of things happened in terms of sea surface temperatures and things like that come together. And you can kind of notice patterns, and you use those types of things to predict the future, because a lot of our computer model guidance, it tries to predict things pretty well, but sometimes it falls short. So it's on us to use those statistical methods to bridge that gap.
So most people listening to this will be really familiar with the weather forecast. Tomorrow's high temperature, percent chance of rain, here's the wind. What are some of the types of variable output in a long range forecast that makes it different than your standard 7-day weather forecast?
Well, the science has not advanced enough to where we could say, all right, July 4th, 2026, you're going to have sunny skies, 85 degrees. We can't tell you that. We're not going to pretend to. But what we'd like to do with long-range forecasting is kind of identify trends. So we're trying to look for areas that might have hotter than normal conditions, maybe a heat wave. We can pick that up. Or maybe a wetter period where thunderstorms and heavier rainfall could impact an area, and that could have impacts on a lot of different things, of events you're trying to do during the summer, sporting events, for example. Utilities will have to react to it and make sure that the lights are always on for us. So we're trying to, as far in advance as possible, pick out the windows of time where those conditions are most favorable. And so people can make long-term planning decisions based on that.
For sure. And the uses are really, really interesting. You might think ahead to, okay, I'm going to have a really hotter and drier summer than normal. That may mean I need to irrigate more and I should plan ahead for that. Or if I'm a farmer and I start looking into what crop do I want to grow this year, we know weather's such a huge variable in that. Having some sense of how the atmosphere is going to help with the growth of that can be a big deal. What were some of the surprising use cases for this long-range forecast that you've found interesting that maybe you didn't think existed when you sort of started your career and advanced over time?
Well, I think one of the more interesting things is that some of the retail users that we have, like larger companies that are going to use this weather to make decisions on where to put things like road salt, shovels, things like that, or during the summertime where you might have some of the outdoor chemicals for pools and things like that. So you'll never believe how many different people have a need for such long-term weather data. So that, to me, that sector was the most surprising because I wouldn't have thought of that when I was growing up in this field.
Yeah, your snow shovel at your local Home Depot or Lowe's doesn't just show up by accident, right? And there's usually a weather forecast that's involved in that. So what and you know how to forecast weather in the short term as well. You're a brilliant meteorologist. What are you mentioned this a little bit ago, kind of using weather models as the guidance for a short-term forecast. What are some of the additional tools and techniques that are unique to long-range forecasting that you might not use looking at tomorrow's forecast outlook?
I think one of the major things that I use that can add some value is monitoring tropical thunderstorm clusters in different areas of the tropics in the world. So they call that the Madden-Julian Oscillation, or the MJO. So if you have anomalous thunderstorm clusters, let's say moving through the Eastern Pacific this time of year, that can correlate to drier than normal and hotter than normal weather in the Pacific Northwest. So those are the types of things that we look at. And over time, we've noticed that sometimes happens right away. And sometimes there's a lag where it might happen a week or two down the road after the thunderstorm complexes show up. And those types of things we build into our forecasts. And the model guidance, to its credit over the years, is getting better at picking up on stuff like that. And we use model guidance to predict where those thunderstorm complexes are going to be. But when you're trying to derive that way out in time, sometimes the models fall a little short in capturing the impacts, and that's what we're here to do, is bridge that gap.
Yeah, so if I could summarize, it's kind of it's a lot of pattern recognition, right? You see, and what's amazing to me, and I've been in the weather game for 25 plus years at this point, still blows my mind how something that occurs way off the coast of Western South America can impact the weather in New York or New England, or there is a chain of events that seems to occur going out. What are some of the other common oscillations, or teleconnections is another term that's used often in long range, that you think have quite a bit of value?
Well, we talked a little bit about the Pacific Ocean, and that's what ENSO and all that is, but also the Atlantic Ocean makes a big difference. So if you look at what we call the Atlantic multi-decadal oscillation, or the AMO, you may have heard somebody bring it up in the past. That's just a measure of how warm the water temperatures are in the Atlantic. And also you kind of look at where the warm water is situated in the Atlantic. All those things can make a big difference. For example, if you have a lot of warmer water in the Gulf and then off of the eastern seaboard during the summertime, you can almost count on humidity levels rising up, because you have a lot more, the warmer water in that region can produce more moisture that is brought northward by weather systems during the summertime, and that can spread a lot of moisture northward. So not only that, when you think about it that way, you also have to think about more moisture available for systems to use for precipitation. So that's when we get into heavier than normal rainfall risk and things like that. So, and we notice, looking over the years, when those water temperatures are warm in those areas, we've had those impacts in the east, at least in the eastern half of the United States, where it's more exposed to that type of flow.
Yeah, I think most people will, and it's been in the headlines a lot here lately, will be familiar with El Nino. You mentioned ENSO. Can you describe a little bit about what El Nino is, what ENSO is, and why it's maybe why it became popular in kind of mainstream media? There's a whole lot of other oscillations out there to look at rather than just ENSO, but why do you think that one has so much popularity?
Well, ENSO is basically a measure of water temperatures in different parts of the Pacific Ocean. So when you talk about El Nino, that means that warmer water temperatures are in the eastern half of the Pacific Ocean. And when you put warm water anywhere in the tropics, that has a large say on where these thunderstorm complexes like to go. So you'll have a circulation that has rising motion over those thunderstorm, over that warm water, and you have more thunderstorms in there, and then that adds latent heat to the atmosphere and impacts the jet stream. So it's basically throwing a rock into a pond and you send waves downstream. The ENSO does it in a certain way. So you have El Nino, it's in the eastern Pacific, and when you have La Nina, you have cooler than normal water in the eastern Pacific, but you have warmer than normal water in the western Pacific. So it drives the thunderstorm complexes further to the west. And when you do that, it changes how the wave guide is. And you have a lot of different impacts based on that. So when we talk about El Nino, and especially, and it even matters what time of year you're in. So it has a lot different impact in the summer versus the upcoming winter season.
I've got to say, as a young kid growing up in the 80s and 90s, the El Nino skit on SNL still remains one of my favorites. I think that was well done by Chris Farley.
But about everything Chris Farley does is well done. It's memorable, and that was definitely great.
Yeah, absolutely. It helped kind of make El Nino sort of the popular thing. And everybody likes to put out their tropical forecast. We are no different. We're going to talk about ours here in just a little bit. How have you seen that process of long-range forecasting improve over time versus maybe when you got started in looking at long-range outlooks? How do you feel the predictability of something like a tropical season or a winter season or any seasonal outlook has improved over time? And why do you think that improvement has occurred?
I think we're getting a little bit better at it. A lot of the tools that we use are more accurate than they used to be. So we not only are we using more oscillations, it used to be everything was more or less on what was, did you have ENSO, or did you have El Nino? Did you have a neutral ENSO? Did you have La Nina? Or you looked at the water temperatures and everything, but we also look at different things. So sometimes you have warmer than normal water temperatures in the northeastern subtropics, for example, of the Pacific Ocean, then that results in cooler water temperatures in the Caribbean. So basically, long story short, we're able to look at more things, and the models are getting better at predicting where those things are going to go. So that gives us a more advanced notice, so to speak, on where the atmosphere is going to go. So better tools, better inputs always equal better outputs. Yeah,
absolutely. So as we look forward to this tropical season, and again, it's we're recording this roughly in May, and it feels early to be thinking about hurricanes, but it's not too early. We've seen a lot of years where we've had storms occurring, before the traditional season, so to speak, in the tropics. So it's time to start looking ahead. What were some of the key elements that you looked at that went into this year's making of the tropical outlook?
Well, first, we always start with ENSO because it is probably the most important oscillation that we use, especially when it's strong. So, for example, right now we're basically at the edge of El Nino and the ENSO neutral sector right now. But by the end of the summer, during the peak hurricane season of August through October, that El Nino could very much be bordering on strong. So when it gets that way, it usually dominates over other elements. So that's usually the first thing that we look at here. And this year, it makes it a little bit easier. But other things, one thing we also noticed that the Atlantic Ocean has a cooler look in the main development region, which stretches from just off the coast of Africa near the Cabo Verde Islands all the way through the Caribbean. And you have cooler water in those sections. But at the same time, you have the warmer water off of the southeast coast and the Gulf. So those are kind of conflicting, because if you have cooler water in the main development region, maybe you get less of those long track storms. But if you have warmer water closer to the coast, a couple of things can happen. You can have close in development where you might have something form within 100, 200 miles of the coast and then come in. Or you could have, if you get one system that sneaks through there and it gets into that region, you can have rapid intensification of storms as they approach. And the problem with that is that you have not a lot of lead time on that sometimes. So what might be just a tropical storm 3 days later could be a Category 3 or Category 4 hurricane, and it could be bearing down on a sensitive area that could be highly impacted by storms. So when we see that warmer water in there, even though we are anticipating El Nino, we still have to have our guard up for those types of impacts as we go through the tropical season.
I think that's really important, and we're going to flash up our official forecast, your official forecast for the year here. That, and I think this is really important. The headlines always are above normal, normal, below normal, but literally it takes one storm to make landfall. I often always go back to the early 90s when Hurricane Andrew hit the south coast of Florida, just south of Miami in the Homestead area. That storm hit in August, and that was the A storm, meaning it was the first named storm of the season. And so you go through June, you go through July, you go through parts of August, and you're like, wow, there's like no tropical activity. This is a quiet year. Boom, major storm happened. I think that's going to be part of what we'll need to watch closely. So I'm going to flash up on the screen for those watching on YouTube or watching on video. This is the 2026 DTN Tropical Outlook. Nate, do you mind walking us through sort of what you expect to see this year?
Yeah, sure. The forecast by numbers, we're going for the named storm forecast of 13, 5 of which should be hurricanes, 3 of which we're anticipating major hurricanes. That is slightly below average for all years since 1995. So relatively quiet season, but there are some things to watch. For example, we were just talking about that close-in development. So we have a highlighted area in the eastern half of the Gulf and off of the southeast coast near the Bahamas. And that's the kind of area that we're looking for. Years in the past, we had an El Nino, especially the stronger one, had some systems pop up through there. So that's the area we're going to have to watch a little bit closer. And then you look way out in the Atlantic, you see slightly enhanced risk. That does look kind of scary. But the one thing these storms have been doing over the years, the El Nino years, is recurving. So we have storms that are drawn northward and then drawn northeastward away from the U.S. coast. So we're going to see a lot of that this summer. So you might have some close passes, though. So we've highlighted slightly off of the southeast coast and not too far away from the northeast. So those areas are still going to have to pay attention. But most of the storms, if not all of them, should be either recurving. And if there's going to be any exceptions, which every season there is one, the odds are they will drift across the northern Caribbean through Hispaniola, maybe, or towards the southern Gulf, maybe even Central America. So even though we have below average risk down there, that doesn't mean that one storm can't sneak through. And Renny, you brought up the perfect case for having to watch out even during a quiet season in 1992. Only 8 total storms that year. So every single time I give a tropical outlook, I bring that up, and it could be an otherwise quiet year, but one storm, everybody's thinking, oh yeah, 1992 was active. It was very destructive, and it was the worst season ever. But yet it only had 8 storms. So these numbers, having less systems give you less of an odds of a hit, but if you get one, you'll remember it forever.
Absolutely. Just a great reminder. It's really intriguing with El Nino. The way when I hear strong El Nino, the first thing I think of is kind of a stronger than normal southern jet stream or subtropical jet stream that moves across. When we talk about wind shear in severe thunderstorms, which means kind of changing wind or increasing wind aloft, that's a good thing for tornadoes and hail and severe thunderstorms. For tropical, it's typically a bad thing. It'll blow a storm apart, so to speak. The other beauty of this is that's the steering current for the most part as these storms are going to move through. And so while there's an enhanced risk kind of to the east of the United States over the broad Atlantic, what you're suggesting here is that that'll be a steering current to actually almost like a blocker, the offensive line to block those storms from actually getting to the coast of the U.S. and move them out to sea. But if a storm forms in the Gulf of Mexico or in the Caribbean, we'll need to watch it carefully because it could quickly spin up and quickly impact, and we'll need to be on guard for that.
I mean, I couldn't have said it any better myself. Those are exactly the types of things we're expecting.
Yeah, absolutely. Well, it should be a super interesting tropical season. While maybe not as many storms are as active, and I'll tell you, our forecasters don't mind if it's a little quieter than normal. That's an okay thing. We don't necessarily want a ton of storms, but that doesn't mean we should let our guard down as we go into the season. Very cool look at our tropical outlook, and looking forward to see how this plays out. So we're going to wrap up this episode with what we call Heat Burst, Nate, which is where we get to do a couple of kind of quick questions about you. What was the storm system that kind of, you mentioned lake effect. Is there a single storm that like got you into meteorology, that got you hyped up when you were a kid?
Well, The blizzard of 93 always comes to mind. I was 14 years old at the time, and it was just incredible. And but most people remember all the snow that was even in the deep south and along the eastern seaboard. And if Syracuse, New York did get 40 inches of snow out of that, that was from the main storm. But what people don't remember, it didn't make the news, is once that system pulled away, there was a period of lake effect and it dropped 3 or 4 more feet. And so it was quite the impactful event up in parts of upstate New York, having to deal with the heavy wet snow first, and then the additional snow behind while you're trying to clean up. So when you have an event like that, that's going to be in people's memories forever, and you get to experience it. When you're interested in science like I am, that kind of just drove my interest right to the peak. So I was able to follow through on that and learn more about it, and be able to apply all the lessons learned from that event and others to make me the meteorologist I am today. So I hate to say I'm thankful for destructive events that are impactful for people, but in this case, it did help me get me to where I am today. So
it is the most conflicting thing ever for us to go through, which is like, yes, we love the crazy weather and the chaos. We don't want it to hurt people. There is a balance in there. Yeah. There's a bit of a balance in there that's kind of hard to synthesize as a meteorologist. We're always conflicted. Is that the most amount of snow you've seen in person?
Yeah, that was the peak. And it was definitely, I spent a lot of times up on roofs shoveling it off, because that was the major impact up there. Is people who didn't remove snow from their roofs might not have roofs much longer.
Wow.
And so I made a lot of money doing that. So the immediate after effect wasn't as positive for me as I could have been, because that was a lot of work.
Learn the value of hard work in a hurry, didn't you?
Well, absolutely. You had to do it. I mean, because if you didn't, a lot of bad things could have happened to people you knew.
There is one open spot on the Mount Rushmore of great forecasts. What's the one you're putting up there that you produce? What's your best forecast you think you've ever put together?
Oh, that's a good question. Oh, man. I have to think on that one for a second. One thing I always remember was the last time we had the strong El Nino, the super El Nino in the 2015-2016 season. It was me and one of the former greats of DTN, Jeff Johnson. We were contemplating on what to do with that. We were able to take the lessons of 1997 and draw it forward, and we forecast a very, very warm winter and not very it wasn't a below average snowfall winter. And that came on the heels of 2 very cold and active winters of 2013, 2014, and 2014, 2015. So there's a lot of momentum when it comes to long range forecasting. So sometimes you lean on what has happened in recent years. And we were coming out of a colder stretch and an active stretch. So forecasting such a warm winter, such a less active winter was hard to do. And we were able to put our heads together, get past all that, and put a pretty good forecast out there. So that's what I think of. And right now we're kind of staring down the same thing here, because we just went through 2 similar winters, and now 2026, 2027 is coming up with a strong El Nino. So we were able to use the lessons from verification from past events to get ahead of that. And we already have that type of winter in the forecast now. And of course, we'll be monitoring to see how things change, because everything's looking like it's going to be a super strong El Nino now. Doesn't necessarily mean it lasts. We have to be on our toes looking at latest model forecasts and the latest observations to see if that needs to be tweaked. So, but it was a nice use case of being able to identify conditions, an event from the past that was going against how things have been going, and be able to get there before a lot of model guidance did, and before a lot of other people were able to recognize that. So that was, to me, that goes up on the mountain somewhere.
I love it. Let's etch it in. That's fantastic. And it's really intriguing, because I think that, you're using essentially 20-year-old kind of history to say, I'm really confident, or I'm going to kind of put my neck out there because I see, pattern recognition. Would you say that that makes you more confident for this year's forecast, having kind of lived through a similar scenario once before, even though it was 11 years ago?
Yeah, it does give me a little bit more confidence. And, back then we were sweating bullets because we didn't know how it was going to turn out. But now, I mean, you're always a little nervous because the atmosphere has a surprise around every corner for us, fortunately and unfortunately. But
Yeah.
I feel better about it now. I'm more experienced since then, and now we have more these type of events to learn from. So every single year that goes in the books, that's another piece of information that we could use and to adjust our understanding of the atmosphere.
I always say weather, we both had full heads of hair when we started this thing. Um, just how this works. It'll make you pull your hair out from time to time, no doubt about it.
Yeah, precious fuel have to pull out too.
That's right. That's right. Okay, very cool. So, final question for you: if you hadn't become a meteorologist, where would your career headed?
I think I would have been in the air. I would have. The other thing I'd like to do be a pilot. That would have been fun. Being able to go to different cities all over the country, all over the world, in many cases, and experience the cultures that you could that were available to you at all times. That would have been fun. And plus, it's I mean, that's kind of adjacent to weather because weather's a significant impact on that as well. So I probably would have been able to use whatever skills I had to help help me in that avenue as well. But if I had to pick one, that would have been that.
Absolutely. I get to travel a good bit for my job, and it's always fun to interact with the pilots. They're, pretty dang knowledgeable about weather because you have to be. It is such a disruptor, and ultimately it's a disruptor to almost every industry, weather is. And so the forecast and insights that you provide truly touch a whole bunch of different supply chains. There will be interested parties in the aviation space wondering what's going to happen this year and how to plan routes accordingly. Logistics, people starting to prepare materials to be ready in case we need to, rebuild quickly after one of these storms. So this type of forecast is often not thought about as much as the regular forecast. And so the skills and info you guys bring is super impressive to me. And Nate, I just want to thank you for jumping on DTNsights today. Super interesting conversation, really valuable insights, and look forward to watching this one become a new candidate for putting on the Mount Rushmore when you absolutely nail this one too.
I appreciate that, Renny, and thanks for having me on. This was a fantastic discussion, and let's just look forward to everybody being safe this tropical season. And hopefully we don't have any high impact events that really ruin anybody's lives out there, because how these things could be life changers for some people.
Absolutely. We will
be prepared.
Prepare for the worst, hope for the best. That's the saying always. Well, thanks everybody for joining us here on this episode of DTNsights. Hope you found this really valuable and interesting. Nate, great job once again. And come back and make sure you subscribe to these podcasts, and we'll get more on the way. Thanks again.
Thank you.